So this is how fast this vehicle or the object is moving towards the north. This is 30 kilometers per hour. That is how fast it's moving towards the north. Now this is how fast it's moving towards the east, 51.96 kilometers per hour. Now let's understand something. What if we do have our angle? Let me just keep this one aside. What if we do have our angle here? 60 degrees. Now, let's say it's moving due northeast 60 degrees. And we have to calculate how fast the object is moving due north and how fast the object is moving due east. Mind you, we have not changed the degree of the angle of the object, or maybe the projectile or the force. Now, you are simply still going to use the same method at which you've used. But in this case, notice that simply what I usually tell my students is, if your angle touches this x plane, use your y coordinate must be used. You can say therefore must be used what? Sine. Now theta. Theta is which the angle. Theta is equals to 60 degrees. It depends on the angle which you have been given. So if the angle is here, so let me cancel this out. And let's say this is 30 degrees. So this theta will be 30 degrees. Now, x plane, which is the east, therefore used what? Cos theta. Now, if it happens that your angle has to fall on the y coordinate, this is it. Happens that your angle has to fall on the y coordinate, then this is 60 plus this is 90 degrees. So this theta will be 60 degrees. Now it's 90. Now therefore your x use sine theta, your y therefore use cos theta. You notice that as the angles have changed, you see that also the signs have changed. Okay, now I know that if it touches the y plane, I can simply remove this. I say y and I say x. So if my angle touches the y, immediately it touches the y plane. Be it here, it touches the y plane. This is the y plane. It touches this plane. I will invert. But immediately my angle was given and it touches this plane, I remain my x-axis as cos, as my y-axis as sine. Now, let's move forward and prove what we said is true. Let's see if our x-axis is going to give us 51.9, I think it's 96, and our y-axis is going to give us 30 kilometers per hour. So let's use that. So we said, how fast is moving towards the north? So therefore, it's going to be, now which is in the positive quadrant, it's going to be plus 60. Now, notice that the angle has changed. Now, we have also changed how we are supposed to use the sign. Instead of us, for our y, which is towards the north, due north, how fast due north, it's going to be 60. Now, instead of it to be, let's just make this one y. Instead of it to be sine 30, here you are going to get cos what? 60 degrees. And that will give you 30 kilometers per hour. You can go ahead and purge to verify. Now, how fast due east. We are just simply going to use what we have written down. Now it's going to be, it's going to be plus 60 sine. You get the point? Sine 60 is equals to 51.96 kilometers per hour. So that is how you use your inclined plane, how to use the sine and the cos in any cases. So imagine this was not supposed to be in the positive quadrant. Now this is supposed to be in the negative quadrant, and let's say this is, because opposite angle is the same, this is 60 degrees, and here you have 60 kilometers per hour. Notice what happens. X becomes negative, y becomes negative. So all of these answers, this is negative, and this is negative. So all of this is negative. But as we all know, there is no such thing as negative speed. Either their relativity is reducing. If the car is relative to me and the car is moving, that means with respect to me, the car is moving in a negative direction, while with respect to the car, I'm moving in a positive direction. Thank you. Please follow, share, and like, and also subscribe. Thank you.